All right, so today we are learning about logarithms. I'm going to ask everybody to put phones away, please. So for some reason, students always think logarithms are going to be really confusing because it's like a whole word in your equation, but it's not that bad. Okay, so a logarithm is defined to be the inverse of an exponential equation. And it's useful in solving exponential equations when your variable is in the exponent. Okay? So you can write an exponential expression or equation here in a logarithmic equivalent. So if I'm saying that, why is that an x? That should be it is an x here, okay. So if I'm saying 2 to the x equals 16, I could also write that as x equals log base 2 of 16. And there are a few terms for these parts. So the base of the exponential, right here, the base is 2. And that base goes here, so log base 2. The exponent of the exponential here is the answer to the logarithm. Okay, so the base of the exponential is the base of the logarithm. The exponent of the exponential is the answer to the logarithm. So a logarithm is literally an exponent. And then this other part, people don't really use a name for it that much, but if you want to give it a name, it's called the argument. I don't know why. If anybody knows why, you can let me know. All right, so it's a pretty simple translation between the two different equations.
Wait, one question.
Yeah.
So this is just the log thing, just like log, that's the exponent?
So this entire expression is equal to the exponent.
Oh. Okay.
So log base 2 of 16 is equal to the exponent. So if I say log base 2 of 16, what I'm really saying is 2 raised to what exponent gives me 16? What would the answer to that be? I heard of 4. Anybody want to agree with 4? Give a different answer. You agree? Yeah? 2 to the 4 is 2 times 2 times 2 times 2, right? And that would give you 16. So on the side here, we can say, oh, well, that means x equals 4. But that's not really even what we're doing here. But it's good when you can figure those things out. Good morning. All right. Here it is with variables. Okay, so whatever is the base of your logarithm is the base of your exponential. The answer to your logarithm is your exponent. And then the argument here that comes after log base b, that's over here. All right, so what we're going to do first is we're going to practice rewriting exponential equations as logarithmic equations and logarithmic equations as exponential equations. And I'm going to do one of each with you, and then I'll let you guys try these others, okay? All right. So 6 to the second power equals 36. First thing I'm going to do is write the word log. And then what's the base going to be? What number? It's 6, yeah. Because 6 is the base of the exponential. So log base 6. Okay, and then next comes the argument. So the argument was over here. What number will I write? It is 36, yeah. Now, sometimes you're going to see this written with parentheses and sometimes without parentheses, and it doesn't matter. Nothing is different. So if I put parentheses here, it's no different than if I didn't put parentheses there. It's just some people write it and some people don't. Okay? So log base 6 of 36 equals, and the answer is your exponent, which is what? 2.
Oh,
yes. You
found
found it? Good. All right. Here I have log base 2 of 32 equals 5. So when I say log base 2 of 32, I'm saying 2 to what exponent gives me 32? Well, that's 5. And now I can rewrite it as an exponential. What would be the base of my exponential? 2? Raised to the 5 equals 32. Now, if you mixed it up and you said like 2 to the 32 equals 5, the next thing you would say is, that doesn't make any sense. And then you would fix it. Okay? All right, so I want you to take a couple minutes to rewrite these. And if you know what x equals in the end for here, go ahead and do that. How negative exponents work, and then how fraction exponents work. Why is 49 to the 1/2 equal to 7? What does that 1/2 power do? Because half of 49 is definitely not 7. Square root, right. So the 1/2 power means square root. The 1/3 power means cube root, okay? So bringing back some of those exponent ideas is going to be helpful here. All right, over here, we did log base 3. 81 equals. And so what we're trying to answer is 3 to what exponent gives me 81? What'd you guys get? 4, good. So here I'm going to put x and x equals 4. And then my eyesight, okay. Log base 5, 1 equals x, so your base is 5. 5 to what exponent gives me 1? What's that? So I'm hearing 0, 1, and -1. So quickly talk to your partners about that. If you want to check it in Desmos, you can. 5 to what exponent gives me 1? People. All right, so x equals 0. All right, so why do we need logs? So I already know if I have 2 to the x equals 8, then x equals what? More than 2. Because 2 to the 2 is 4, right? 2 to the 3, yeah. So I know how to figure this out. 2 to the 3 equals 8. I know 2 to the what equals 1? Good. And I can even do 2 to the x equals 1/2. What's x in that case? -1. So these are all things that we can figure out with exponents. But what about 2 to the x equals 5? Right? It seems like maybe it would not even work, right? 2 to the x equals 5. Think about that for just a moment. All right? So for 2 to the x equals 5, even though we can kind of guess and check our way to a pretty close answer, open up Desmos and I'm going to show you how to do log base 2 of 5. So I'm going to rewrite this first. Log base 2 of 5 equals x. All right, I'm giving you a second to open up your Desmos. You're going to go into the keypad and find functions. All right, and again, I wasn't recording, so I'm going to just show real quick. Under functions, you go down to the calculus section and you find log base A, and then you type in log base 2 of 5 to get approximately 2.32. And we were right, weren't we, that it was between 2 and 3? And actually, instead of equals, I'm going to do like the approximately equal to. Okay. Here we go. Special basis for logs. There are 2 logs that are more special than any other logs. They are the common log and the natural log. The common log is so special that if you just write log and you don't write a base, that means common log. So if I just write log with no base, that's common log. If you have a calculator that's like a scientific calculator and you see that there's a button on it that just says log, that's log base 10. Okay? So if I just write log with no base, that means log base 10. That's weird. Okay. So you can put log base 10, like with a 10, into the Desmos calculator, and it'll be fine with that. But if you just put the word log in there, then it will also do log base 10. All right, natural log is a logarithm that does occur a lot in nature. It's also used a lot in interest. Remember that we used Euler's number here when we were doing continuously compounded interest? Yeah. All right, so it's called ln, and ln means log base e. Now remember, e is not a variable. E is an irrational number, like pi is an irrational number, about 2.7, but it has a lot more digits than that. So what we're going to do is we're going to do a little bit more practice. So here's my exponential. 10 to the 1 equals 10. The b is 10. The y is 10. And the x is 10. Oh, sorry. So the b is 10, the y is 1, and the x is 10. So I'm going to do log. What's the base of my log? 10. Do I write 10? No, that's weird, right? All right, so log base 10. You could even like write it and then erase it if that is something that messes with your head, okay? So log the base is 10, but then we erase it because we're like, oh yeah, you don't write it when it's log base 10, okay? And then we put the x, right? So the x is the argument over here. It's this 10. And that's going to equal your exponent 1. So log of 10 equals 1. And then over here, I have log of 1,000. What's the base of this logarithm? It's 10. So this time, I'm going to write in the 10 just so that I can remember to use it when I'm writing my exponential. 10 raised to the 3 equals 1,000. Okay? These are going to be a little bit trickier than the ones we did on the other side, but I want you to try them, and then we'll go over them. Okay. 10 to the x equals 1. So log base 10, but I'm not going to write the 10. Then what number? 1. Good. Equals x. 10 to what exponent gives me 1? Maggie and Sally say 0. Yeah? That's right. Anything to the 0 gives you 1. All right. Log of 1/10 equals x. What's the base? I don't see a base. What's the base? It's 10. All right, so 10 raised to what? 10 raised to the x, good, equals 1/10. All right, 10 to what exponent gives us 1/10? I know 2 people have an answer, but I'm waiting to see if we can get another answer in here. 10 to what exponent gives us 1/10? So Gideon says -1. Sky, do you agree? Sally, do you agree? Yeah. Josiah, you agree? Very good. All right. X equals -1. All right. We're switching over, right? This next one is not common log. It's what kind of log? Okay. So I like E-log. I like uncommon log, but it does actually have a name. What is it called? Right here, guys. Natural log. So ln, you could think of it as log natural, but really it's natural log. Okay, so you could start by writing log base e, right? But we're going to change it. We're never going to end on log base e. So log base e of what number? What comes next? I know you guys want me to write ln. I'm going to write ln in a minute. I'm just doing an intermediate step. Yes, 7.39 equals 2. But then we say, oh, we don't really write log base e. What do we write? ln. So ln 7.39 equals 2. All right. ln means log base e, so I'm going to rewrite it because it's going to help me write this as an exponential. So I replace ln with log base e so that it would help me rewrite it. So my base is e, my exponent is 1, and my argument is e. So the first thing I did was rewrite ln as a log base e. And then I finally wrote it as an exponential.
What about the 10?
So remember, ln is not log base 10, it's log base e. So log without a base is base 10, and ln is log base e. It's okay, it's two things in one, so we got this. All right, has anybody had a chance to try the last row yet? I want to give you a minute to try it, okay? It is a little bit complicated, but it gives us a very interesting result. Okay, I'm writing this as a log. What will be the base of my log? Where are you guys getting these things from?
Where's he getting root from? It's X.
Okay, the base of the log is the base of the exponential. What is the base of the exponential? B is the base of the exponential. I get that the exponentials switch sides and that can be confusing, but the base of the exponential is over here. So log base B. Okay? Next comes the argument, not the exponent. So the argument is what? Log base B of x. Oh, sorry. Okay. Log base B of x equals the exponent. What's the exponent? All right. So the exponent is all of this, log base B of n. Okay? So it's log of base B of the argument, and that equals the exponent, which is log base Bn. Do you notice how this is the same and this is the same? That means that x equals n. Yes, I get that. So what I'm trying to show you is that it makes perfect sense that when the base of the exponential is the same as the base of the logarithm, they cancel out. Because remember, they are inverses. So the base of the exponential matches the base of the logarithm. They cancel out, leaving you with just x equals n. We're going to do it this way too. So this one is a logarithm. We're going to write it as an exponential. What's the base of the exponential going to be? So b, the answer to the logarithm is the exponent. And that equals, what's the argument? B to the n. All right, do you see how the bases are the same? So that means x equals n. And again, when the base of the logarithm equals the base of the exponential, they will cancel, leaving you with x equals n. So we're going to see that applied down here. What's the base of ln? Not 10. E. E. The base of ln is e. If it helps, you can rewrite it as log base e of e to the 2. The base of the log matches the base of the exponential, so they cancel, and this simplifies to be 2. Okay, I'm going to do one more with you, and then I'm going to have you try C and D. Actually, just C. because D is a little bit different. All right, is that a cube root? Okay, cube root can be rewritten as what exponent? 1/3, yeah. So this is going to be ln of e to the 1/3. Now you can rewrite that as log base e to the 1/3 if you want, or you can just remember that the base of the log is matching the base of the exponent and they will cancel, giving you just 1/3. All right, so try C real quick. Okay. Now, here I have log base 14, 14. And I'm not quite sure what to do with that. So here's what I'm going to do. I'm going to put an equals x after it, and then I'm going to rewrite it and see what that comes out as. Okay?
Miss Bro,
Mm-hmm.
do we have a project on this unit?
Yep.
Oh, this one?
Mm-hmm.
Wow. That'd be too hard to attest.
We have a quiz next class, though. Not 2 classes, sorry. We have a quiz in 2 classes, and then we have a project at the end. Okay. All right, can we rewrite this as an exponential? What's the base going to be?
Log 14.
So it is log base 14, right? So I'm rewriting it now as an exponential. All right, so log base b x equals y, b to the y equals x. The base of the log becomes the base of the exponential. So what's the base going to be? I heard it up front. What was that? 14. So 14 to what exponent?
14. X.
X. 14 to the x equals the argument, which is just 14. Very good. Okay. So this is the exponential equivalent of the logarithm. Notice I had to add that equals x there to kind of make sense of this. If you're not making sense of something, adding the equals x might help you rewrite it. All right, so 14 to what exponent gives you 14? I heard an answer over here. I see an answer over there. 14 to what exponent gives me 14?
1.
1, yeah. X equals 1. All right, look at E. I don't see a base. What's the base? 10. I'm going to do the same thing. I'm going to put equals x after it so I can rewrite it. Can you try to rewrite it and then see if that helps you solve it? And then the same thing with F. Try E and F.
The parentheses don't matter, right?
Okay. All right, so the base is going to be what number? 10. The exponent? X. And the argument? 1,000. All right, and Taryn, what does x equal? Good. All right, so I'm going to do the same thing with this one. I'm going to put in that base of 10 and equals x. And I'm going to write 10 raised to what exponent? X, good. Equals 1 over 100. What kind of exponent do I need for a reciprocal? Thanks, Alexa. And then it's not -1 this time. It's negative what? -2. Good. Because 10 squared is 100, right? So 10 to the -2 will be 1 over 100. Now, what if I'm just not feeling it and I want to know what the log of 1 over 100 is? What could I do? Could use Desmos, right? Let's see. All right, so remember I showed you to do log base 2. You've got to go deep into the functions. If it's just log, you can type it. If it's log base 10. So you can always check your answers on Desmos. See? -2. Okay. All right, we have 4 practice problems. Please try those practice problems. I'll give you 2 more minutes, and then we'll check our work. Who do we have? Who can share one? I see 2 hands. We have more. All right. Morgan, which one do you want to do? The first one? Okay, what'd you get?
I got 14 base negative of 93 minus 7
Okay, I think I interpreted that. Is that what you meant to say up there? Oh, you can't see, my bad. Unfreeze. Is that what you meant to say?
Yeah.
Okay, good. All right, Gideon, you want one? Can you tell me the step first? How would I write it as an exponential? Oh, you can do a different one. You want to do C or D? Okay. Yeah, but how do I write it as a log? So what I want to do is rewrite them. Sometimes they're solving and sometimes they're not. I know you know how to do it. You just didn't know what I wanted there. All right, so redo it. Let's give Blaine one. Go ahead, Blaine.
The second one, 2 to the 6.
2 to the 6 equals x. Good. All right, so Blaine wrote 2 to the 6 equals x, and then she says x equals 64. Did anybody else get that? X equals 64 in the end? Taryn got it, Sally got it, Izzy got it. Okay, so x equals 64. All right, Sally, you want to do the next one?
Which one is that?
C.
Log 12.
So it's log base 12.
Log base 12.
Mm-hmm.
144 equals
Good.
Just for all.
Yes.
Put the number on the bottom or the top.
So an exponential equation will have an exponent. A logarithmic will have a base down there.
Oh, so if you're writing it with log, you put it on the bottom.
Yes. And if you're writing an exponential, it will be up there. They're not the same numbers, but they're both lower than the other. So see how 12 is lower than the 2, and the 12 is still lower than the 144. Yeah. All right, who wants the last one? D. Go ahead.
Log
Mm-hmm.
5 125 equals x.
Excellent. All right, guys, and then what does x equal? 3. Good.